This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our StrikeTape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back. This is the Uptime Podcast. I'm your co-host, Dan Blewett. On today's episode, we've got 6 main topics. First off, we're going to chat about Siemens Gamesa potentially making a pretty big loss here with having to replace faulty gearboxes. We're going to chat about an interesting multi-use project for potentially floating offshore wind turbine platforms. So I think this is sort of a natural progression. So we'll chat about some of the ways aquaculture might come to floating wind. We're going to talk about a little bit of lightning news where AI is getting closer to predicting where lightning will strike in advance, which is crazy. We're going to talk about ELF, so some electromagnetic stuff as far as bearings and gearboxes. We're going to chat about robotic blade critters, the blade bug, pretty interesting technology, crawling up wind turbine blades and doing some inspections, repairs. And then we're going to talk about cleaning, which is something that I don't think gets enough press when it comes to not only wind turbines just in general, but also the lightning effects as well, talking about that. So Alan, let's start here with Siemens Gamesa. So it looks like they've lost 70 million euros, article from Energy Watch, on faulty gearboxes.
Ouch. That's a problem,
not great.
Right? Yeah, gearboxes, you see that, well, Siemens Gamesa is now pushing their, how many, is it 14 megawatt direct drive? 14 DD, is that right? Okay, so
yeah.
So the gearboxes are just a failure point, which is why the direct drive starts to make a little more sense. The issue with gearboxes is there's vibration components that can happen. Obviously, lubrication is a big deal. Any sort of material failure, metal failure inside those things can be a problem. So it's just not a huge news point, but I think it sounds like they had some cracks in the case, which are, I guess, probably fatigue related or material related. They got a material issue with the casting that they didn't expect. And, what are you going to do besides replace them? There's really nothing to do about it, because once you start, there's one thing if you can get inside and start taking out different parts of the gearbox and replacing them. But if you start cracking the case, it's like the cracking the block on a internal combustion engine. It's pretty much over. There's not a lot you're going to do about that. You can't weld it back up. That's just not a thing. So this is a big problem. And I think they found it, from what I could read, they found it actually on their test bed first, which is where you want to find those things before you start seeing
their
problems.
4 megawatt prototype. Yeah.
Which is where you want to find them, right? You want to try to. This is a very common engineering thing to do. Is you can't run your piece of equipment out for 20 years and then sell it, because then no one will want it, because it's 20-year-old technology. So what you do is you get out a year or two in front with the technology, and you have it running and operating, and then you can detect those likely failure modes and then pass that along to your customers. Say, hey, these little repairs or mods need to be made to keep it up and running, and then that's part of the expected part of the deal. But when you have sort of a significant catastrophe, it's not catastrophic, but it could turn into catastrophic if you left unattended. You want to fix that up front, and in this particular case, it's a main component of the turbine. So, ouch, it's a problem. It's a big problem.
Yeah, absolutely. Of course, for a huge company like Siemens Gamesa, 70 million seems like a lot, but probably just a little drop in the bucket for them, and obviously a lot better than maybe it getting out of hand and being a much bigger problem than that.
So, sure.
Because they said they don't expect for it to be much more than the 70 million that's already been spent on repairs and replacement.
Yeah,
so
right. Because you can envision the kind of failure modes it could get into, from just leaking oil to gear failure to overheating conditions, which are all bad. So it's really it's really great, that the wind turbine companies, when they develop these products, are looking a couple years out in the future, which is what they should be doing. So hats off, even though the outcome is not great, at least hats off. You're making the industry safer by doing that.
Well, yeah, and these events in business are newsworthy because, big loss, people want to know, on the investment side and all that stuff. But, like every business and even person, like, a person gets X amount of parking tickets a year, right? Or speeding tickets, or, your car gets, vandalized, or, a tree falls on it. Like there's just so much amount of loss that you have in your regular life. Remember Apple a couple of years ago tried to invest in that huge Sapphire manufacturing plant. Lost like $1 billion. It just didn't work.
Yeah.
And Apple just kept chugging right along. So, I'm sure all these companies have these sort of like built in, like you just know you're going to stub your toe as a person, as a business, like X amount of times throughout the year. And you just, chalk it up to trying and just keep moving forward, I guess.
Right. Yes.
But speaking of innovation, this is a cool thing. I think this is a really interesting idea. Offshore wind with an aquaculture facility built in. So they could potentially grow, shellfish or do all sorts of projects depending on the climate, where they are in the world. But with these offshore floating platforms, I think that seems like a pretty natural progression. So in this article by renews.biz, just talking about the OPEX, the offshore platform for energy competitiveness, they're setting up a 15-month feasibility project to see, can we sort of combine and make this like an aquaculture lab in addition to obviously being a functioning floating wind turbine. How do you feel about this, Mr. Engineer?
The dual use makes a lot of sense because it's an existing piece of hardware that's out there and you can adapt it.
Do more with it.
Yeah, it does. The only thing that worries the engineer part of it is, will the extra events that are happening on your platform somehow degrade the performance of the platform somehow? Like, would it cause additional corrosion? Would the shellfish attaching themselves to these pylons essentially cause issues going forward? From the engineering standpoint, you're like, I don't like anybody messing with my design. I know what it is. I know if it's left alone, it'll be fine, right? And when you start putting extra things on it, especially have to do with the wildlife, it just adds that level of, I'm not sure this is a great idea. But it does lend itself into looking at it, and it needs to be developed before it gets instituted on a larger scale. But there are opportunities there, right? I think there are real opportunities there because you have this really fixed platform, and if you can grow shellfish off of it, and it just makes life easier to do that, and then great. And I think there's some other opportunities there too, because you got this fixed platform. You could instrument it to monitor ocean temperatures, waves. You can monitor the area with cameras for whatever reason, for ships coming in and out, or if you're in places where there's a lot of nefarious traffic coming in and out, you could actually load these with sensors and that kind of thing. So there's a lot of opportunities to make it a dual use. It's just engineering wise, you just never want your little baby to be altered, right? So I think there's probably a little bit of hesitation there.
Yeah, well, and it also would make this thing from essentially an uninhabited thing in the ocean to an inhabited, like if there's going to be aquaculture, there's going to be people there. And if this is going to be X amount of miles offshore, or just even a couple thousand yards offshore, which I'm sure it's going to be farther than that, now like people have to live there some amount of the time. You have to have some sort of accommodations, probably. Like if there's a research lab, people can't just be going back and forth 5 hours by boat. It's not going to make any sense from a time efficiency standpoint. So then it's like, okay, well now there's people living here for 2 weeks at a time or a month at a time. How does that change the noise the turbine can make and all these other different things? Like now there's just like, it probably becomes really complex really fast. It's my guess too.
Sure it does. And there's always kinds of insurance issues about being on the platforms, and right, you can take your boat and equipment up to the platform, but once you cross onto the platform, you're at a different level of restrictions and training that are involved, right? So it does have a level of difficulty. And as soon as you put humans on anything, from the design standpoint, there's added risks, like people do inadvertent things that can cause problems. So usually
Alan, I got to stop you. This is the way we combine the podcasts into so hear me out here. You got the floating offshore wind farm that makes the world's finest oysters, whatever. Then we get the EVTOL market, which we talk about in the Struck podcast, and you have these EVTOLs come in to grab the day's, harvest, take them back to shore. So now you're combining wind power with EVTOL, electric takeoff, vertical takeoff and landing. It's everything's coming together.
See, I think this answers the other problem, which is in order to get to some of these offshore sites, you need to be on a boat for a while. And right now, the only answer right now is helicopters. That's the only faster way to get back and forth, but they cost so much to operate. You're going to see electric aircraft going back and forth to these platforms. That is inevitable. Yeah, sure. That's coming. And yeah, it does change the dynamic quite a bit, because then you don't have to be on site all the time, because the cost of getting to and from just went way down. Way down. And yeah, you could have fresh seafood. You could have fresh shellfish coming to your dinner plate from turbines. It's possible. It's very, very possible.
There you go. So last thing on our news segment here, AI can potentially predict where lightning will strike 30 minutes in advance. So Alan, you're the lightning guy. Take us through this. Is this real, or is this
sure,
pie in the sky?
No, it's not pie in the sky. But when I read the article, I had to take a double take, because what pieces of information are you using to determine where lightning will strike? And is it just looking up at the sky and saying, yeah, there's a thunderstorm cloud? Because that's usually your first indicator, like, wow, that's a really tall cloud and it looks awful dark. And those kind of clouds generate lightning, and they generate lightning tends to be on the front end. It depends, honestly, but there you can, if you know there's a cloud there, you generally know where the lightning is going to come out of that cloud. And there's also like a rate that because it takes a certain amount of time after a discharge or a lightning flash that it takes for the cloud to kind of charge back up again and then do it again. So there's sort of a repetitive nature to these things. So you do that and create a artificial intelligence algorithm to help predict that? Yes, you could, but do you really need one? I wasn't sure what the need was here. Like, we know that lightning is going to strike, but I can use my eyeballs to do that too. What added feature is there to it? Because how are you going to use the data? Unless they're using the data to protect like stadiums of people, or soccer fields, or football, as it's called in most part of the world. You don't want people out on the field getting hurt by lightning strikes. Is that where that was going? I assume that was part of it.
Well, I mean, is there any way to protect things from lightning? So if we know it's going to strike in this given area, like, do we like shoot like something over to like in movies, you like dive in front of the bullet to protect someone else? Like, is there any? What's the application? Can we fire something off to take the lightning strike? Like, I mean,
yeah.
Well, practical example, you were talking about the space shuttle, right? Like, they figured out in the 60s that the space shuttle would actually cause lightning strikes. So to prevent that, they would fire off, was it missiles, or was it lasers? It was lasers, right?
Well, they have these rocket launch systems, which they still do down in Florida at the University of Florida, that have very thin copper wires behind them. So they're essentially model rockets that have very fine copper wires, and they fire them off and they'll actually trigger lightning events. So it's a way to discharge the cloud, so to speak. So yeah, you could do something like that. I think the one that keeps getting popped up year after year after year, which hasn't really been implemented widely yet, is lasers to discharge a cloud, to basically create a lightning event and discharge it before it got to something you cared about, like a wind turbine. But we really haven't seen much of that. And there is some randomness to lightning. That's part of its allure, is that it just happens randomly. That's what we call it, force majeure, a lot of times, because it is sort of this random event. And I don't know if you're ever going to take the randomness out of it. You may be able to detect where it's likely to occur, but the randomness part is still there.
All right, so in our second segment here, we're going to start off with ELF. So, Alan, you're an electrical engineer. We're talking about electrical line frequency and some of the issues that this can have. So, interesting article out of windpowerengineering.com by David Clark of CMS Wind. He says about 50% of drivetrain failures are in the generator, and some of this can be stray electrical current. So what is electrical line frequency? What can that do to a wind turbine? Why is that a problem?
In the generator itself, there can be stray currents running around inside, and it depends upon the way that the generator has been designed. But essentially, it goes like this. So you've got this rotating machine that is rotating through magnetic fields, and that creates electricity. That's how you create electricity. So you got a rotating magnetic fields in copper wires and loops, and that coupling creates electricity. But you also have a lot of stray currents, or you can have a lot of stray currents. And those stray currents can create problems if those stray currents go through mechanical pieces, particularly rotating mechanical pieces like bearings. So anything where you have a very finely machined part that is rotating, if you get sparking inside of that because you have stray electrical currents, essentially, that those little sparks, even though they seem harmless, each one as an individual spark is relatively harmless. But as they add up over time and you start to pit the bearings or pit the raceway or pit the bushing, those little pinpricks start to add up into something. And over time, you start grinding away at bearing interfaces and bushing interfaces, and the wear and tear explodes, and so that you essentially shorten the lifetime of that generator and the bearing. And so you want to be able to have some sense of what's going on in there and whether that event is happening. This is why the early generator testing is really important, because if you're looking at lifetimes, sometimes it's some of these events internally to the generators you can't really see all that well, detect all that well, but you see them in other ways. And the way that described in the article is, hey, you start to see vibration because that bearing isn't as smooth as it once was when it was factory new. All of a sudden, you've got this grinding surface coming together, and it'll eventually destroy itself given enough time, and you don't want that. So you want to try to control those stray electrical currents as much as you can, or quote unquote ground them out so you don't have them running through the bearings and the raceways and all that kind of stuff. And so from a risk mitigation standpoint, early development testing and all the monitoring that happens at the OEMs plays a big part into eliminating that. But it sounds like there's either things that have changed or design has changed, and then that's getting in service. And if you're seeing that in service, it's a big issue. If you're seeing it, especially if you're seeing it in vibration data for your generator, that's a problem. That's a really big problem.
So moving on, this is a really interesting thing, the blade bug. So they've done some testing, and this is a robot that will walk on a wind turbine blade even in its vertical position. And they have, it looks like a couple different configurations, but the one they've sort of tested recently, it looks like it has, I think 6 or 8 feet, depending. But it's just picking them up and putting them down just with little suction cups, and it uses vacuum to walk on this blade. And obviously the potential here, this has not been tested on a live wind turbine yet, not like moving, but in the field, out at sea potentially.
Yeah.
But obviously, the future, Danny Ellis from SkySpecs talked about obviously the imperative use of drones and how important they are, but also he was talking about potentially robots, clinging to blades and walking up and down and doing repairs. So he was kind of mentioning this sort of concept before. And to me, it seems really slow. Obviously, this is a prototype. This is like the first phase of this getting somewhere, right? We need this to start somewhere, which is great. But it seems like, just looking at the design, which is fascinating, but it seems like it's a long way from this thing having different tools and actually grinding into a blade or making a repair, doing this, doing that. It seems like that's pretty sophisticated, on top of just the fact that this is a really sophisticated device just to walk on the darn thing, right? Am I wrong here?
You're right. It's even to walk on it. If you think about,
it's impressive. It's really impressive. Yeah.
Yeah, and blades aren't the cleanest thing in the world. So if you're trying to essentially grab hold or suction cup your way up a blade, the surface contours and all that make it a little more difficult. So just to stick to the side of the blade is impressive, and then to move along and not fall off, which is also not easy because, especially if the wind's blowing, I mean, there's a lot of forces going on there that would want to eject your little robot.
Are these? Is it windy? Is it windy where they put these, these machines?
Occasionally it is, yeah. So
tends to be, yeah.
Tends to be a little windy.
Got it.
And also in places where it's wet, right? And in places where it's cold, and places where it's extremely hot. So you're putting this robot in the really rough environment and saying, I'm going to take into fact all these variables and I'm going to not fall off, which is remarkable. And even to attempt it is, I think, difficult to conceive because
it's for sure.
It's just way too many variables of are you always attached? And you ever seen you probably don't watch these movies, but you ever seen the Mission Impossible movie where Tom Cruise is suction cupped his way up the side of the skyscraper with the little gloves? They're actually gloves that stick to the side of the building. It's not even suction cups. It's just these suction cuppy gloves.
I think I've watched at least one of the Mission Impossibles. Not they weren't like on my list, but I know James Bond has done that at different points, right? Like every spy has done that at some point. I mean, it's like old news for spies. Come on.
So what always happens in all those movies, right? The suction cup gives way and your hero falls.
Chaos.
Right? Yeah. Which is the first thing you think about any sort of suction cup device is like, oh, it's only going to work most of the way, and then something tragic's going to happen, and then the story unfolds from there. So, yeah, it's an uphill battle. So even if they get the technology right, I think just the perception of the technology is going to make it a little bit difficult to gain traction. But if it works, it works. And that's what it comes down to. If it works and can show that it saves somebody from being on that blade for a long period of time, it will be adopted. It will be adopted.
Yeah. Well, and I was wondering out loud, well, not out loud, but internally, how does this thing get up there? Well, it looks like they, go up tower traditionally on top of the nacelle, and then, all right, go little doggy, and there starts marching down the blade. But obviously, way down the road, maybe there's a drone that lifts it up into place and just shoves it right where it needs to go. That's probably obviously the ideal, right? To have humans on the ground.
Right.
Although I guess going up the, traditionally through the center of the tower is not a big deal either. No. So, but obviously, if these are offshore platforms, the best scenario would be one dude just goes out there with all the equipment and just like push a button, which is, what SkySpecs drones and other drone companies do, and just push a button and it does its thing. One drone goes inspects the blade, and then it comes back down and picks up the bug and takes it up to the spot, and then it does its thing, like their own little team essentially, right?
Yeah.
The guy tells the drone what to do. The drone makes a plan, and then the drone takes the construction crew up there, which is just the robots.
See, this is so popular mechanics, and I don't know if you've ever back in the day when the 70s and 80s, and Popular Mechanics would have a lot of articles about robots and technology, and you're like, that'll never happen. It kind of put it in the realm of flying cars, but now we're getting close to flying cars, so now it's time for the robots to come in too. So all this is going to happen in the next, I think, realistically, in serious applications, it's in the next 10 years. We're going to be talking 10 years from now going, that happens all the time. It just does. Yeah.
And at some point, the drone probably just flies up, and then, it sprouts its feet, just like an airplane, puts its landing gear down, and it just hovers closer and sticks to it. Yeah. And that's that. So it's all just one integrated thing. Yeah. And then just when it's done, it just takes back off, flies off the blade, and comes on down.
Yeah.
So
it's going to be
cool.
that easy.
And it's eventually, but that's a lot of complexity to get to that point. Plus battery life. That's the other thing. It's a lot of energy to get up there, hover, do all this stuff, and then come back down.
Yeah, but we have self-driving electric vehicles, and if we can do that, then we can put robots on turbine blades, no sweat. That's just a matter of time.
So last topic today, drone, well, not just drone, but wind turbine cleaning. So I don't think a lot of people think about this. Obviously, they're these big shiny white things, but Alan, they don't really stay shiny white that long, do they?
No, very little.
So somebody's cleaning these gigantic machines.
You see the videos and LinkedIn bits from Aronis, which has a it's a very fascinating company. I don't want to get into it too deep, but essentially they have sort of a rope-based system. They got 4 ropes that can lift. It's not a robot, but a mechanism, I'd call it, up and down the wind turbine blades. But they also have an ability to clean them because they can manipulate up and down along the blades, a cleaning robot, so to speak, which in the videos is fascinating because you don't realize how dirty the blades get unless you've been around them enough to know like they're dirty, and any kind of dust, particle, smoke, debris that's in the air is getting on those blades, and one is creating a little bit of turbulence and drag, so it's not as smooth as it once was, and 2, from the sort of the lightning perspective, all that debris and dust and particles and whatever else is attached to it makes the blade shell slightly conductive. And all those little, and especially if it's salt from the ocean, and there's salt in pretty much any bit of air, you're going to get that on the blade, and all of a sudden your lightning protection system doesn't work like you think that it should. And we get pictures all the time of wind turbines where there have been lightning strikes that have happened further from the tip, meters from the tip. 5 meters, 7 meters, 12 meters from the tip. You're like, what is going on there? Well, all the debris on the outside of the blade is slightly conductive. And what happens is the lightning protection system, which is usually a bunch of receptors on the surface, when those receptors become energized, they just start reaching out everywhere that's conductive. And so it actually, instead of reaching out to the sky, it'll also reach down the blade because that's a very conductive thing. And it's just sort of it's a path of least resistance. So you can either jump out into the sky, which is pretty resistive, or I can just kind of shoot down the blade just to energize the blade up, which is what happens. And then bad stuff happens subsequently. But cleaning the blade minimizes that a good bit. But you rarely see, unless there's been like a smoke or some real contaminant on the blade, you really rarely see them cleaned. But I think as we get discussing the 20-year lifespan, does it make sense to clean them every couple of years? The answer is probably yes. Depending where you are in the world, the answer is probably yes, because it keeps the aerodynamics up. It should help minimize some of the lightning issues that occur as the blades get dirty. Right? And just make the performance better. And if it doesn't take that long to do it, then why wouldn't you do it? If you're already inspecting the blades with the system, which probably you are, then while you're there, why are you not cleaning the blades? Because it doesn't really cost you anything at that point. They're already there.
Yeah, and doing some research, there's a lot of companies that do this, that do wind turbine cleaning. Some of them go up ropes. It just depends. But it seems like using drones is becoming more and more of a prevalent thing. This video I found by Mashable on YouTube just shows a drone that has an electrical cord actually, and so that allows it to stay in the air indefinitely and support, with higher voltage, I guess, support, pumping water up there to it. So it's just up there hanging out as long as it needs to just keep pumping up water and just blasting the blade, which seems like definitely the most efficient way to do it rather than send people up there. Because for all the hazards being up there, if you're up there with a power washer, that seems awful. Because, anyone who's ever power washed anything, you're just getting a ton of spray back in your face.
You're getting really wet.
And being wet with safety equipment and all that high off the ground.
And it's windy and cold, probably.
Yeah, that seems... So let's keep going with the drone cleaning. That seems like the definite way to go.
Yeah. But
yeah, it's really interesting. I hadn't thought much about it, but, you see a lot of them and they're pretty pearly white, and they definitely can't stay like that forever. You're right. Especially in the harsher environments. And especially underneath the nacelle, that's where there's, like the blades are they're going to connect with rain, and they're going to sort of self-clean to an extent, I'm sure. But underneath the nacelle is where it seems like they get pretty grimy because
oil,
nothing's going to spray that off.
Right. Yeah. Oil and grease, if they've had, especially if a gearbox let loose or they've had some sort of spill, which happens, right? And that just goes right down the tower. And then it's sticky. You know how oil gets when oil dries out. It's sticky. So then you get all this other crud sticking onto the sticky oil. You just want to get it off of there because it can also trap water.
And it kind of bakes on there after a while too. You're like not going to be able to get it off very easily.
Salts and debris and stuff get stuck in it, and then it's sitting against the tower. You don't want to start a corrosion issue. You want to get that stuff off. So it makes a lot of sense.
Yeah, it's just one of those things. Like I said, probably one of the things that flies under the radar a little more about these massive machines that does get taken care of sooner or later, just probably not, maybe really often intervals. Maybe it's every year, 2 years. If you're out there and you're listening, shoot us a message. How often does your wind farm get cleaned? Let us know. All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install Strike Tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.